Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
A data scientist has created a BigQuery ML model and asks you to create an ML pipeline to serve predictions. You have a REST API application with the requirement to serve predictions for an individual user ID with latency under 100 milliseconds. You use the following query to generate predictions. Select predicted_label, user_ID from ml.predict, model dataset.model, table user_features. How should you create the ML pipeline? The options are: Option A, add a where clause to the query, and grant the BigQuery data viewer role to the application service account. Option B, create an authorized view with the provided query. Share the dataset that contains the view with the application service account. Option C, create a Dataflow pipeline using BigQuery I/O to read results from the query. Grant the Dataflow worker role to the application service account. Option D, create a Dataflow pipeline using BigQuery I/O to read predictions for all users from the query. Write the results to Bigtable using Bigtable I/O. Grant the Bigtable reader role to the application service account so that the application can read predictions for individual users from Bigtable.
To arrive at the correct answer, we focus on the keywords, serve predictions for an individual user ID with latency under 100 milliseconds.
The correct answer is option D, create a Dataflow pipeline using BigQuery I/O to read predictions for all users from the query. Write the results to Bigtable using Bigtable I/O. Grant the Bigtable reader role to the application service account so that the application can read predictions for individual users from Bigtable.
Why is this correct? D. BigQuery is an analytical database and cannot provide single-row read latency under 100 milliseconds. Bigtable is a NoSQL wide-column database that offers single-digit millisecond latency, making it the ideal storage backend for serving pre-computed predictions to a REST API. Why are the others incorrect? A. BigQuery is not designed for low-latency operational queries. Querying BigQuery directly for a single user's prediction will significantly exceed the 100 millisecond latency requirement. B. Creating an authorized view does not change the underlying query execution engine. BigQuery will still fail to meet the sub-100 millisecond latency requirement for the REST API. Why are the others incorrect? C. Reading results via Dataflow doesn't solve the latency issue if the application has no low-latency database to fetch those predictions from. Dataflow is for processing, not low-latency serving.
You are building an application to share financial market data with consumers, who will receive data feeds. Data is collected from the markets in real time. Consumers will receive the data in the following ways: real-time event stream, ANSI SQL access to real-time stream and historical data, batch historical exports. Which solution should you use? The options are: Option A, Cloud Dataflow, Cloud SQL, Cloud Spanner. Option B, Cloud Pub/Sub, Cloud Storage, BigQuery. Option C, Cloud Dataproc, Cloud Dataflow, BigQuery. Option D, Cloud Pub/Sub, Cloud Dataproc, Cloud SQL.
To arrive at the correct answer, we focus on the keywords, real-time event stream, ANSI SQL access to real-time stream and historical data, batch historical exports.
The correct answer is option B, Cloud Pub/Sub, Cloud Storage, BigQuery.
Why is this correct? B. Cloud Pub/Sub handles the real-time event stream. BigQuery provides ANSI SQL access for real-time and historical data analytics. Cloud Storage offers cost-effective storage for batch historical exports. Why are the others incorrect? A. Cloud SQL and Cloud Spanner are operational databases, not designed for large-scale analytics on real-time event streams or massive historical data. C. Cloud Dataproc is a managed Hadoop/Spark service and is less optimal than BigQuery for providing simple ANSI SQL access to real-time streams. D. Cloud SQL is a relational database not suited for large-scale analytics, and Dataproc lacks the seamless ANSI SQL interface for real-time streams that BigQuery offers.
You are building a new application that you need to collect data from in a scalable way. Data arrives continuously from the application throughout the day, and you expect to generate approximately 150 gigabytes of JSON data per day by the end of the year. Your requirements are decoupling producer from consumer space and cost-efficient storage of the raw ingested data, which is to be stored indefinitely near real-time SQL query. Maintain at least 2 years of historical data, which will be queried with SQL. Which pipeline should you use to meet these requirements? The options are: Option A, create an application that provides an API. Write a tool to pull the API and write data to cloud storage as zip JSON files. Option B, create an application that writes to a cloud SQL database to store the data. Set up periodic exports of the database to write to cloud storage and load into BigQuery. Option C, create an application that publishes events to Cloud Pub/Sub, and create Spark jobs on Cloud Dataproc to convert the JSON data to Avro format, stored on HDFS on persistent disk. Option D, create an application that publishes events to Cloud Pub/Sub, and create a Cloud Dataflow pipeline that transforms the JSON event payloads to Avro, writing the data to cloud storage in BigQuery.
To arrive at the correct answer, we focus on the keywords: decoupling producer from consumer, space, and cost-efficient storage, near real-time SQL query.
The correct answer is option D, create an application that publishes events to Cloud Pub/Sub, and create a Cloud Dataflow pipeline that transforms the JSON event payloads to Avro, writing the data to cloud storage in BigQuery.
Why is this correct? D. Cloud Pub/Sub properly decouples producers from consumers. Dataflow enables streaming transformation. Cloud storage provides cost-efficient indefinite storage for raw data, and BigQuery satisfies the requirement for near real-time SQL querying of large datasets. Why are the others incorrect? A. Pulling an API does not effectively decouple producers from consumers, and cloud storage alone does not support near real-time SQL querying. B. Cloud SQL is not designed for continuous high-volume ingestion, 150 gigabytes per day, and periodic exports do not meet the near real-time SQL query requirement. C. Storing data on HDFS using persistent disk is not a cost-efficient long-term storage solution, and it lacks the native near real-time SQL capabilities provided by BigQuery.
You are running a pipeline in Dataflow that receives messages from a pub/sub topic and writes the results to a BigQuery dataset in the EU. Currently, your pipeline is located in Europe West 4 and has a maximum of 3 workers, instance type N1 standard 1. You notice that during peak periods, your pipeline is struggling to process records in a timely fashion, when all 3 workers are at maximum CPU utilization. Which 2 actions can you take to increase performance of your pipeline? Choose 2. The options are: Option A, increase the number of max workers. Option B, use a larger instance type for your Dataflow workers. Option C, change the zone of your Dataflow pipeline to run in S-Central 1. Option D, create a temporary table in Bigtable that will act as a buffer for new data. Create a new step in your pipeline to write to this table first, and then create a new pipeline to write from Bigtable to BigQuery. Option E, create a temporary table in Cloud Spanner that will act as a buffer for new data. Create a new step in your pipeline to write to this table first, and then create a new pipeline to write from Cloud Spanner to BigQuery.
To arrive at the correct answer, we focus on the keywords: Dataflow, maximum of 3 workers, instance type N1 standard 1, maximum CPU utilization, increase performance.
The correct answers are option A, increase the number of max workers, and option B, use a larger instance type for your Dataflow workers.
Why is this correct? A. Increasing the maximum number of workers allows Dataflow to scale horizontally, distributing the processing load across more compute nodes to relieve the bottleneck. B. Using a larger instance type scales the workers vertically, providing more CPU and memory per node to directly address the maximum CPU utilization constraint. Why are the others incorrect? C. Moving the pipeline to a US region while the BigQuery dataset remains in the EU will introduce significant cross-region network latency, decreasing performance. D. Adding Bigtable as an intermediate buffer adds unnecessary architectural complexity, cost, and latency without solving the underlying worker's CPU bottleneck. E. Using Cloud Spanner as a buffer introduces unwarranted complexity and latency. It does not resolve the compute capacity limit, causing the performance degradation.
You have a data pipeline with a Dataflow job that aggregates and writes time series metrics to Bigtable. You notice that data is slow to update in Bigtable. This data feeds a dashboard used by thousands of users across the organization. You need to support additional concurrent users and reduce the amount of time required to write the data. Which two actions should you take? Choose two. The options are: Option A, configure your Dataflow pipeline to use local execution. Option B, increase the maximum number of Dataflow workers by setting max number workers in pipeline options. Option C, increase the number of nodes in the Bigtable cluster. Option D, modify your Dataflow pipeline to use the flattened transform before writing to Bigtable. Option E, modify your Dataflow pipeline to use the cogroup by key transform before writing to Bigtable.
To arrive at the correct answer, we focus on the keywords: Dataflow job, slow to update in Bigtable, support additional concurrent users, reduce the amount of time required to write the data.
Correct answers are Option B, increase the maximum number of Dataflow workers by setting max number workers in pipeline options, and Option C, increase the number of nodes in the Bigtable cluster.
Why is this correct? B. Increasing max number workers allows Dataflow to scale horizontally up to a higher limit, adding more compute resources to process and write data faster. C. Adding more nodes to the Bigtable cluster increases its throughput capacity for both read and write operations, directly supporting more concurrent users and faster updates. Why are the others incorrect? A. Local execution limits processing to a single machine's resources, which is suitable only for testing and would severely degrade production performance. D. The flattened transform simply merges multiple P collections. It does not address scaling compute resources or improving write throughput to Bigtable. E. The cogroup by key transform performs a relational join on P collections. It adds processing overhead and does not improve write performance or cluster scalability.
You have several Spark jobs that run on a cloud Dataproc cluster on a schedule. Some of the jobs run in sequence, and some of the jobs run concurrently. You need to automate this process. What should you do? The options are: Option A, create a cloud Dataproc workflow template. Option B, create an initialization action to execute the jobs. Option C, create a directed acyclic graph in Cloud Composer. Option D, create a bash script that uses the Cloud SDK to create a cluster, execute jobs, and then tear down the cluster.
To arrive at the correct answer, we focus on the keywords: run on a cloud Dataproc cluster on a schedule, run in sequence, and some of the jobs run concurrently. Automate this process.
The correct answer is Option C, create a directed acyclic graph in Cloud Composer.
Why is this correct? C. Cloud Composer provides managed Apache Airflow, which uses directed acyclic graphs, DAGs, to effectively schedule and orchestrate complex workflows, easily handling dependencies for both sequential and concurrent Dataproc jobs. Why are the others incorrect? A. Dataproc workflow templates are used for defining job execution graphs but lack built-in time-based scheduling capabilities, requiring an external scheduler to fully automate the process. B. Initialization actions are intended for configuring cluster nodes or installing software during cluster creation, not for scheduling or orchestrating the execution of Spark jobs. D. Relying on a custom bash script introduces unnecessary operational overhead and fragility, requiring you to manually build and maintain scheduling, error handling, and complex dependency logic.
You are building a new data pipeline to share data between two different types of applications, jobs generators and job runners. Your solution must scale to accommodate increases in usage and must accommodate the addition of new applications without negatively affecting the performance of existing ones. What should you do? The options are: Option A, create an API using App Engine to receive and send messages to the applications. Option B, use a cloud pub/subtopic to publish jobs, and use subscriptions to execute them. Option C, create a table on Cloud SQL, and insert and delete rows with the job information. Option D, create a table on Cloud Spanner, and insert and delete rows with the job information.
To arrive at the correct answer, we focus on the keywords: share data between two different types of applications, jobs generators and job runners, scale to accommodate increases in usage, accommodate the addition of new applications without negatively affecting the performance of existing ones.
The correct answer is option B, use a cloud pub/subtopic to publish jobs, and use subscriptions to execute them.
Why is this correct? B. Cloud pub/sub is a scalable, asynchronous messaging service that decouples publishers, job generators, from subscribers, job runners. This allows seamless scaling and the addition of new applications without impacting existing system performance. Why are the others incorrect? A. Creating an API with App Engine introduces tight coupling and synchronous communication, which is harder to scale and maintain when adding new applications compared to a dedicated messaging service. C. Cloud SQL is a relational database, not a message queue. Using it to manage job queues introduces polling overhead and limits scalability, potentially creating performance bottlenecks as usage increases. D. Although Cloud Spanner is highly scalable, it is still a relational database and not designed for decoupled event messaging or job queuing, leading to unnecessary complexity in application coupling.
You need to create a new transaction table in Cloud Spanner that stores product sales data. You are deciding what to use as a primary key. From a performance perspective, which strategy should you choose? The options are: Option A, the current epoch time. Option B, a concatenation of the product name and the current epoch time. Option C, a random universally unique identifier number, version 4 UUID. Option D, the original order identification number from the sales system, which is a monotonically increasing integer.
To arrive at the correct answer, we focus on the keywords: Cloud Spanner, primary key, performance perspective.
The correct answer is option C, a random universally unique identifier number, version 4 UUID.
Why is this correct? C. A version 4 UUID generates random values, which evenly distributes write load across Cloud Spanner splits, avoiding hotspots and optimizing database performance. Why are the others incorrect? A. The current epoch time is sequentially increasing, which causes sequential writes to target the same split, creating performance bottlenecks known as hotspots. B. Concatenating product name and epoch time groups writes by product. Popular products will still cause hotspots because their writes will be sequential by time. D. A monotonically increasing integer causes all new inserts to be routed to the same split, creating hotspots and severely degrading write performance.
Data analysts in your company have the Cloud IAM owner role assigned to them in their projects to allow them to work with multiple GCP products in their projects. Your organization requires that all BigQuery data access logs be retained for 6 months. You need to ensure that only audit personnel in your company can access the data access logs for all projects. What should you do? The options are: Option A, enable data access logs in each data analyst's project. Restrict access to Stackdriver logging via Cloud IAM roles. Option B, export the data access logs via a project-level export sync to a cloud storage bucket in the data analyst's projects. Restrict access to the cloud storage bucket. Option C. Export the data access logs via a project-level export sync to a cloud storage bucket in a newly created projects for audit logs. Restrict access to the project with the exported logs. Option D. Export the data access logs via an aggregated export sync to a cloud storage bucket in a newly created project for audit logs. Restrict access to the project that contains the exported logs.
To arrive at the correct answer, we focus on the keywords, Cloud IAM Owner Role, all BigQuery data access logs, only audit personnel, data access logs for all projects.
The correct answer is option D. Export the data access logs via an aggregated export sync to a cloud storage bucket in a newly created project for audit logs. Restrict access to the project that contains the exported logs.
Why is this correct? D. An aggregated export sync routes logs from all projects to a central cloud storage bucket in a dedicated project. This secures logs from data analysts who are project owners, ensuring only authorized audit personnel can access them. Why are the others incorrect? A. Data analysts have the IAM owner role in their projects, so they can modify IAM policies to grant themselves access to Stackdriver logging. B. Since data analysts are owners of their projects, they would have full access to the cloud storage bucket located within their project. C. A project-level export sync only exports logs for the specific project it is created in. It cannot aggregate logs across all projects like an aggregated export sync can.
Each analytics team in your organization is running BigQuery jobs in their own projects. You want to enable each team to monitor slot usage within their projects. What should you do? The options are: Option A. Create a cloud monitoring dashboard based on the BigQuery metric query/scanned_bytes. Option B. Create a cloud monitoring dashboard based on the BigQuery metric slots/allocated_for_project. Option C. Create a log export for each project, capture the BigQuery job execution logs, create a custom metric based on the total slotems, and create a cloud monitoring dashboard based on the custom metric. Option D. Create an aggregated log export at the organization level, capture the BigQuery job execution logs, create a custom metric based on the total slotems, and create a cloud monitoring dashboard based on the custom metric.
To arrive at the correct answer, we focus on the keywords, monitor slot usage, within their projects.
The correct answer is option B. Create a cloud monitoring dashboard based on the BigQuery metric slots/allocated_for_project.
Why is this correct? B. Cloud monitoring provides a built-in BigQuery metric, slot/allocated_for_project, which directly allows monitoring of slot allocation and usage specific to individual projects without requiring custom log exports. Why are the others incorrect? A. The query/scan_bytes metric measures the amount of data read by queries, not the slot usage. C. Exporting logs to create a custom metric is an unnecessary, complex workaround because a built-in cloud monitoring metric for slot allocation already exists. D. An aggregated organization-level log export is overly complex and does not natively provide per-project visibility to individual teams as easily as the built-in metric.
You are operating a streaming cloud Dataflow pipeline. Your engineers have a new version of the pipeline with a different windowing algorithm and triggering strategy. You want to update the running pipeline with the new version. You want to ensure that no data is lost during the update. What should you do? The options are: Option A. Update the cloud Dataflow pipeline in flight by passing the update option with the job name set to the existing job name. Option B. Update the cloud Dataflow pipeline in flight by passing the update option with the job name set to a new unique job name. Option C. Stop the cloud Dataflow pipeline with the cancel option. Create a new cloud Dataflow job with the updated code. Option D. Stop the cloud Dataflow pipeline with the drain option. Create a new cloud Dataflow job with the updated code.
To arrive at the correct answer, we focus on the keywords: streaming cloud Dataflow pipeline, different windowing algorithm and triggering strategy, update the running pipeline, ensure that no data is lost.
The correct answer is option D, stop the cloud Dataflow pipeline with the drain option. Create a new cloud Dataflow job with the updated code.
Why is this correct? D. The drain option allows the pipeline to finish processing buffered data before stopping, ensuring zero data loss. Since changing windowing or triggering strategies is incompatible with in-flight updates, draining and restarting is the correct approach. Why are the others incorrect? A. In-flight updates using the update option are not supported when the new pipeline version changes the windowing algorithm or triggering strategy. B. An in-flight update requires the same job name, not a new one. Additionally, changing windowing or triggering strategies makes the update incompatible. C. The cancel option immediately halts processing and discards in-flight data, which violates the requirement to ensure no data is lost during the update.
You need to move 2 PB of historical data from an on-premises storage appliance to cloud storage within 6 months, and your outbound network capacity is constrained to 20 megabits per second. How should you migrate this data to cloud storage? The options are: Option A, use transfer appliance to copy the data to cloud storage. Option B, use sudo-cpj to compress the content being uploaded to cloud storage. Option C, create a private URL for the historical data, and then use storage transfer service to copy the data to cloud storage. Option D, use Trickle or Ion Ice along with sudo-cp to limit the amount of bandwidth sudo utilizes to less than 20 megabits per second so it does not interfere with the production traffic.
To arrive at the correct answer, we focus on the keywords: 2 PB, within 6 months, outbound network capacity is constrained to 20 megabits per second.
The correct answer is option A, use transfer appliance to copy the data to cloud storage.
Why is this correct? A. Transfer appliance is a hardware solution designed for securely migrating large volumes of data offline. This is necessary because moving 2 PB over a constrained 20 megabits per second network connection is mathematically impossible to complete within the 6-month timeframe. Why are the others incorrect? B. Compressing the data using sudo-cpj is insufficient. Even with compression, moving 2 PB over a 20 megabits per second link would take years, missing the 6-month deadline. C. Storage transfer service performs online migrations which rely on network bandwidth. With only 20 megabits per second available, it cannot transfer 2 PB of data within 6 months. D. Throttling the transfer speed to less than 20 megabits per second only exacerbates the bandwidth limitation, ensuring the 2 PB migration will take significantly longer than 6 months.
You receive data files in CSV format monthly from a third party. You need to cleanse this data, but every third month the schema of the files changes. Your requirements for implementing these transformations include executing the transformations on a schedule, enabling non-developer analysts to modify transformations, providing a graphical tool for designing transformations. What should you do? The options are: Option A, use data prep by Trifacta to build and maintain the transformation recipes, and execute them on a scheduled basis. Option B, load each month's CSV data into BigQuery, and write a SQL query to transform the data to a standard schema. Merge the transformed tables together with a SQL query. Option C, help the analysts write a Dataflow pipeline in Python to perform the transformation. The Python code should be stored in a revision control system and modified as the incoming data schema changes. Option D, use Apache Spark on Dataproc to infer the schema of the CSV file before creating a data frame. Then implement the transformations in Spark SQL before writing the data out to cloud storage and loading into BigQuery.
To arrive at the correct answer, we focus on the keywords: executing the transformations on a schedule, enabling non-developer analysts to modify transformations, providing a graphical tool for designing transformations.
The correct answer is option A, use data prep by Trifacta to build and maintain the transformation recipes, and execute them on a scheduled basis.
Why is this correct? A. Cloud Data Prep by Trifacta provides a visual, graphical interface for data exploration and transformation, allowing non-developer analysts to easily build and modify recipes. It also fully supports scheduled execution. Why are the others incorrect? B. Writing and maintaining SQL queries in BigQuery requires developer-level skills and does not provide a graphical tool for designing transformations. C. Writing and modifying a Dataflow pipeline in Python requires significant programming skills and lacks a graphical interface, contradicting the core requirements. D. Using Apache Spark on Dataproc requires advanced programming skills and does not offer a graphical interface for non-developer analysts to design transformations.
You want to migrate an on-premises Hadoop system to Cloud Dataproc. Hive is the primary tool in use, and the data format is optimized row columnar, ORC. All ORC files have been successfully copied to a cloud storage bucket. You need to replicate some data to the cluster's local Hadoop distributed file system, HDFS, to maximize performance. What are 2 ways to start using Hive in Cloud Dataproc? Choose 2. The options are: Option A, run the CTL utility to transfer all ORC files from the cloud storage bucket to HDFS. Mount the Hive tables locally. Option B, run the CTL utility to transfer all ORC files from the cloud storage bucket to any node of the Dataproc cluster. Mount the Hive tables locally. Option C, run the CTL utility to transfer all ORC files from the cloud storage bucket to the master node of the Dataproc cluster. Then run the Hadoop utility to copy them to HDFS. Mount the Hive tables from HDFS. Option D, leverage Cloud Storage Connector for Hadoop to mount the ORC files as external Hive tables. Replicate external Hive tables to the native ones. Option E, load the ORC files into BigQuery. Leverage BigQuery connector for Hadoop to mount the BigQuery tables as external Hive tables. Replicate external Hive tables to the native ones.
To arrive at the correct answer, we focus on the keywords: migrate an on-premises Hadoop system to Cloud Dataproc. Hive is the primary tool in use. All ORC files have been successfully copied to a cloud storage bucket. Replicate some data to the cluster's local Hadoop distributed file system, HDFS, to maximize performance. 2 ways to start using Hive in Cloud Dataproc.
The correct answers are Option A, run the CTL utility to transfer all ORC files from the cloud storage bucket to HDFS. Mount the Hive tables locally. And Option D, leverage Cloud Storage Connector for Hadoop to mount the ORC files as external Hive tables. Replicate external Hive tables to the native ones.
Why is this correct? A. You can use the CTL utility to transfer data efficiently from cloud storage directly to the Dataproc cluster's HDFS, enabling fast local data access for Hive. D. The Cloud Storage Connector enables mounting ORC files directly as external Hive tables, which can then be easily replicated into native HDFS tables to maximize performance. Why are the others incorrect? B. Transferring files to an arbitrary individual node's local file system does not make them available in the distributed HDFS, preventing proper cluster-wide Hive access. C. Copying all data to the master node's local disk first creates a performance bottleneck and risks exhausting the node's storage capacity before moving it to HDFS. E. Loading the ORC files into BigQuery introduces an unnecessary intermediate step, increasing migration complexity, latency, and costs compared to reading directly from cloud storage.
You are implementing several batch jobs that must be executed on a schedule. These jobs have many interdependent steps that must be executed in a specific order. Portions of the jobs involve executing shell scripts, running Hadoop jobs, and running queries in BigQuery. The jobs are expected to run for many minutes up to several hours. If the steps fail, they must be retried a fixed number of times. Which service should you use to manage the execution of these jobs? The options are: Option A, Cloud Scheduler. Option B, Cloud Dataflow. Option C, Cloud Functions. Option D, Cloud Composer.
To arrive at the correct answer, we focus on the keywords: batch jobs that must be executed on a schedule, interdependent steps that must be executed in a specific order, executing shell scripts, running Hadoop jobs, and running queries in BigQuery, run for many minutes up to several hours, retried a fixed number of times.
The correct answer is option D, Cloud Composer.
Why is this correct? D. Cloud Composer is a managed Apache Airflow service ideal for orchestrating complex pipelines with interdependent steps, scheduling, and automatic retries across varied tasks like shell scripts and Hadoop jobs. Why are the others incorrect? A. Cloud Scheduler is designed for simple, time-based job scheduling. It cannot natively manage complex workflows with interdependent steps, nor does it track the state of long-running tasks. B. Cloud Dataflow is meant for running Apache Beam data processing pipelines. It is not an orchestrator designed to manage disparate tasks like shell scripts and Hadoop jobs. C. Cloud Functions is meant for short-lived, event-driven functions. It is not suitable for orchestrating complex, interdependent batch jobs that can run for several hours.